and we will let you go ahead and tell the group what else you do. And it is now, the stage is yours. Thank you.
All right, bear with me here. I did lose a monitor, so I don't know how this is going to work now. That's awesome. Let me see. I'm gonna have to. I can share my. Oh yes, excellent. Okay. Share. All right.
Looks good.
Okay. So a little bit of background about us and myself outside of the bio. Yeah, MBI started in 1986 as the premier biotechnology manufacturing scale-up site. Its initial launch was to promote biomanufacturing in the region and to spin off companies, create technologies, proprietary technologies that can be licensed, spin off companies. So not so much research based. And then the fee for service kind of stuck. It provided income. And then that's kind of where I stepped in. I stepped in 2008. Mindy Wilson kind of helped me get the job. I appreciate that. I also want to maybe take a step back. I appreciate the opportunity to speak here. Thank you, Purnima and Mindy, for inviting me and bringing me on. I'm honored. So I started out in the lab making solutions, doing things with kind of more lab skills. I didn't have a whole lot of skills in the pilot plant, but I was in the pilot plant at that time. I then learned some skills in the pilot plant after a few years, was trained on how to, sterilize tanks, CIP tanks, things like that. At that point in time, though, I worked on cars when I was a kid, so I was mechanically inclined. They loved that. That was one of their top questions when I interviewed, which I thought was odd. I was so prepared to do a test and do more molarity calculations right there on the fly because Mindy had scared me half to death about it. So I quickly fell into the mechanical side of things, but I've done everything there. I've been in the hood. I have done data analysis. I've talked to clients. I've worked with various different biotech equipment, anything from pipetting and making solutions to climbing in the fermenter and taking things apart. But anyway, without further ado, let's move on. So overview of a typical pilot plant fermentation. So I don't know everybody's background, and I had a fun time trying to figure out what to tell you guys. But so I'm just going to kind of start from the beginning. I'm kind of banking more on the question side of things at the end because there's, like Purnima said at the end of Jim's presentation, it's just a tip of the iceberg. I could talk for hours about this stuff. So we need to prepare media. We have to make solutions, feeds, assemblies to steam onto the fermenters. We have to sometimes we have to start the seed train weeks ahead of time. We were actually doing one where we're in the middle of a run, but we're starting the next week seed train early this week because seed one's 120 hours long. So so we can do a lot of prep while we're actually starting the whole run. While the seed train's going, we'll be pressure testing vessels, sterilizing vessels, getting everything around for those. This is just a bird's eye view, so bear with me. And then throughout this whole entire process, though, we need to make sure we're keeping everything sterile. We're following aseptic technique from our lab to the autoclave, from the autoclave to the pilot plant, everywhere in between. And when you add it all up, it's really, really complicated. And there are a lot of areas where things can go wrong. We'll get into more of that later. So sampling seeds for viability. So once we have everything ready, the seed train's ready to move on, we will, we'll sample, check OD, we'll check it, always check it under the scope, make sure that we don't have any obvious signs of contamination. Is this yeast or is it bacillus? Let's take a look. Then we will go ahead and we'll inoculate potentially sequential seed trains, stepping up the growth of the organisms, which I'll explain in more detail later. Then once we're in the fermenter, we're sampling, we're monitoring, we're collecting data, we're making sure we don't foam out and blow foam all over the pilot plant, things like that. And then afterwards, we'll either kill it, or if there's downstream processing on it, we will send it down to the other end of the pilot plant where we have a group that does downstream processing. I will also touch up on that a little bit. And then we'll clean up, and we'll either already be preparing the next week's run or the next run, depending on the length of the fermentation. All right, so I kind of alluded to this earlier. There's a lot of things that can go wrong. So, there's a big difference between, I think I go touch on this a little bit later, but there's, we have to maintain proper aseptic and sterile technique. What we try to do is we try to do every, so sometimes we have connections that we have to do. We'll try to do those in the hood, but we can't always do that in the hood. So if we can't, we have things that I'll touch on later and how we do that. We do excessive hood cleaning. Every time we go into the hood, we go out of the hood. We work with spores a lot. We work with, first of all, we work with everything. Probably should have led with that. We don't do, we do a lot of fee for service work. We get a lot of client rotation. We try not to turn anything away. So spores tend to get everywhere and are hard to kill. So we've gotten bit by contamination a lot. So we've definitely had to ramp up our aseptic and sterile techniques and cleaning the hood. But one thing that is different from, I think, the lab scale, actually it is, one thing that quickly right out of the gate I learned when I walked into the pilot plant was everything's bigger. And with bigger comes a lot of challenges.
Bigger problems.
You got autoclave time, container size and volume. For example, if I take a polypropylene 50-liter carboy and I fill it to the brim and I autoclave it, I will not be able to sterilize that solution. That will not work. The most that we can do we have the Cadillac of autoclaves, Steris something or other, but it is beautiful medical grade autoclave that we got, and it can only do 10 liters of volume at a time. For the most part, it depends on the solution. Anti-foam, we can't do more than 10 liters. And you can't do plastic on plastic. So if you have a catch tray that's plastic and you have a 10-liter plastic container full of liquid, you're going to fail your cycle. Also, you want to make sure the plastic you're putting in the autoclave is compatible with the autoclave. We have learned that the hard way several times as well. I wish I had those pictures, but I don't, unfortunately. So also even like weighing out the media. So, we have a lot of yeast extract and peptones and awesome powdery stuff that just gets all over the place. So you're constantly donning PPE and your N95 respirator, just to weigh out media, or take that media and dump it into the tank. Sometimes we have to bring in 55-gallon drums of glucose, and we're adding 55-gallon drums of glucose to a tank, one drum at a time, to fill about 2,000 liters to feed a 3,000 eventual batch fed total volume at the end, 3,000 liter fermenter. So but then there's probe calibrations. I have spent hours trying to calibrate probes for a run during a pressure hold test. You know, that's when we'll do our probe calibration so that they're ready for sterilization, so we don't have a backup on sterilization day, especially for the big tank, because it's about 3.5 hours from the time you load the media to the time you're in cool down and you're done sterilizing your tank. And then you've got, you know, the microscopic analysis, like I was talking about earlier. Sometimes that's critical. You know, like it's hard to catch contamination on plates because, well, I mean, we that's when we catch it the best. It's the easiest way to catch contaminations on plates, right? But those plates are, they grow up in a day. We're already inoculated, and we need to know now if there's any remote sign of contamination, or we're going to lose $40,000 to $50,000 just like that, if not more. It depends on the length of the fermentation and how much work we have to put into it. But typically, when we're contaminated, we've already put in the bulk of the work. You know, the production for the I'm sorry.
This is Rob. I have a quick question.
Yeah, sure. Go ahead.
Have you thought about using MALDI-TOF for those? Because you can quickly see what's on that plate with that gas GC mass spec type.
No, I'm not familiar. No, but I will definitely look into it. That's for sure.
Yeah, I mean, they have a lot of clinical labs will screen their plates from patient samples with the technique called MALDI-TOF, and TOF stands for time of flight. And they have you know, different pattern-based proteins that they can quickly scan and survey and find out what is in that plate. So that's a good technique.
Okay. So where was I? So, you know, we'll look under the scope. A lot of times what we'll see are, you know, swimmers. You know, we're looking for a non-modal rod, and we've got swimmers all over the place, you know, or spores or yeast, more rare for the yeast side of things. By the way, we love working with yeast. That's awesome. Very robust organism. Really don't worry about a lot of contamination with those bugs. Then there's also proper assembly of widgets or other various different assemblies that we use on the fermenter or on our seed tanks. If they're not, you know, I've had a widget in my hand. I'm going to put this thing on the equipment and it's wrong. What do I do now? I have to do this now. Everything's time-based, whether it's adding an addition to the fermenter, everything's on a schedule, and going back and redoing the widget, autoclaving it, getting it back out, steaming it on the tank, you're instantly an hour and a half out. So, and we try to keep things close to the inoculation time to avoid contamination. And then, of course, vessel sterilization. A lot of things can go wrong in vessel sterilization, especially, you know, the bigger the tank, the more things that can go wrong. You know, from my experience, the bigger the tank, it's like the exhaust, and in exhausting that out, there's a lot of things that can cause contamination in an exhaust system based on its design and how it has to work. But there's lots of other things. So like I alluded to, the size of everything. You know, that was one thing that kind of hit me first thing, was like, oh, I'm not pouring into a little beaker. I'm taking, you know, a 20-gallon carboy and I'm filling a 4-liter plastic graduated cylinder or something like that. Or, I mean, we work a lot in mass. We try to eliminate volume and use mass and density a lot as best we can. But that's definitely not always the case. It's just, we find it a little more accurate. And but like this one picture with the nitrogen tanks, this is actually kind of, we're doing a lot of anaerobic work, and we're kind of like in between sizes. We don't do enough anaerobic work, and we don't use enough gas to warrant having air gas install a 750-pound CO2 and nitrogen tank or whatever. That's going to cost us, you know, $150,000 or something like that. So we'll order dewars, and we have to set up, these dewars and just the size and scale of all these things that are a lot easier on the bench just become a lot more complicated when you go to scale up. We also have, like I alluded to with the sugar, like we need the proper equipment to load some of these materials, and sometimes that's not thought of by the client, and we'll get this huge 500-liter tote of glucose in the door, and we're like, what do we do with this? And we're instantly in that, okay, we got to figure it out. And then also, filtration. Filtration, whether it's filtering out media or air or whatever, it's always larger, more expensive, and adds a whole nother complication to the process. That's an understatement, but and vague. But I go into that a little bit later.
Have you ever had a problem with the FDA with regard to your liquid nitrogen? Reason I bring it up is when we were producing Gardasil at Merck, we used liquid nitrogen to flash freeze vials before they went into a lyophilizer. And the FDA came out for their factory inspection and said, can you prove to us that your liquid nitrogen is sterile, that there's nothing in it?
So we don't have that. So that's a great question. We are a non-CGMP, non-FDA licensed facility, if you will. We do so none of our work can be used on animals or humans. We've made some things that can. We have a particular process where we are making a medical grade plastic that does go into humans, but we're somehow they're able to get around FDA compliance at our site because they're changing it later on. We're growing it up and sending it down the line, and then down the line they can delineate.
Well, at that point, you're raw material.
Yes, thank you very much. Yes, absolutely.
So I'm curious. So Dennis, liquid nitrogen being sterile, did you have to aliquot it out and see if it would grow colonies?
They actually have to look in it and see if there were spores, because one of the problems in eastern Pennsylvania is aspergillus is in a lot of the soil, and you track it into areas on your shoes. So you have to have, you change shoes, or you have those tacky mats, because it really does lead to contamination of bioprocessing areas, or even animal facilities with the aspergillus that's in the dirt around the buildings.
And so your question was around the liquid portion.
Liquid nitrogen, right? They want to know if it was sterile.
Yeah.
Yeah. So for our purposes, right, we're just using it. We crank open the pressure building valve, and we're using it to supply gas and overlay gas to our anaerobic fermentation. So we filter the gas.
Oh, okay.
Yeah. We filter the gas going in. We actually I have it plumbed upstream of our air inlet our air on our process air, and I plumb it in such that you close the valve and you're no longer able to provide air to the fermenter. It's only CO2, nitrogen, or whatever mixed gas you need.
But you'd have to filter it to a size that nothing could get in. So in terms of bacteria and everything.
Yep. So the filters we use to filter both of our exhaust and our air inlet is 0.2 micron.
Mm-hmm. So Joey, I have a question regarding that. Do you have to certify your filtration process and validate if those are expired, unexpired, all of those things with the filters?
I would think so.
Kind of.
If you're not working on our GMP,
that's true.
A burden.
Right. So
that's
we
true.
Get a lot.
He gets away with more.
Yes. I do. Very much so, and I love it. That one company that we're making the medical grade plastic for, which is about all I can say, by the way, that does bring a whole level of the quality control to it. We have actually changed a lot of our practices based on what they want us to do, and then we don't want to do it for one and not the other. We're always building upon. I mean, if we could, we have a vacant lot right next door, we would build a CGMP facility right next door. Absolutely would. We're hoping that happens. We'll see. There's actually, we are a university and we are providing fee-for-service work. So you can see where there's some interesting legal implications to that. So we're flying under the radar, I think, right now. But anyway, one thing that, it definitely was covered when I was going to school, but not so much, not what I learned on site. There's a huge difference between sterile and aseptic technique, and there is a difference, and we definitely have like a strong delineation between the two, and we try our darndest to do most sterile technique we possibly can, and leave aseptic technique for other people, but it just doesn't work. We can't do it 100% of the time. And of course, like I said, our biggest reason why is because of spores. We've done a lot of Bacillus subtilis work, and it gets everywhere. It's everywhere. I mean, we used to do Afex bioprocessing. We actually still have the Afex 3 not continuous, but batch-fed bioreactors upstairs, the 1,000-gallon models that Dr. Bruce Dale worked on when he was still working at MSU. He's retired, I think, but anyway, so that brought in a lot of B sub, a lot of B serious, a lot of B everything, and other stuff. But I mean, our primary contaminant is B sub. We've actually, so what we'll do when I talk about contamination a little bit later, but we can also, we try to fall back on, okay, what is our sterile technique? What is our aseptic technique? And where was the flaw? What did we do wrong that got us this contamination? All right, so a typical seed train, these are actually on-site fermenters. So, we'll start, you can't go from start to finish. You can't just take a little epi tube of some stuff and dump it in. So we have to step it up in a seed train. And this is the crux of the run. Like sometimes we'll have 4 seed trains. We'll go from, sometimes it's a glycerol stock, or it can be a plate. If it's we've worked with fungal colonies where we're trying to take, where we're making we're taking some of the spore mat that's grown, making a solution, adding whatever we need to it to buffer it up, and then inoculate with it. But typically we'll start out with either 1 or 2 seeds where it's a flask, and then we move it into a smaller size vessel. Sometimes we're able to go from the flask into, the sartorius there, the 100-liter. Sometimes that 100, like with all of our anaerobic work, that's production, right? Antibiotic production, that's the Cadillac right there. That's what's doing, that's making millions and millions of dollars a batch for big pharma. So, but we're using it as an overglorified shake flask half the time. But it's really nice. Anyway, so we have to grow it up to get our, proper OD, proper cell density per volume before we get it into 1 KF3. If not, then the bugs stay in lag phase a lot longer. So, and sometimes they don't come out, and it's just too much. There's too much of a gradient there that they just can't overcome. So that's more rare, but usually it just takes them a lot longer. But then by that time, it's not working right anyway. Either the subspecies that has evolved at that point it's just not doing it. So it is critical to make sure that you have the right cell density per volume when you're moving to different steps. Make sure you get the right volume. Sometimes we don't take, we try to leave excess in there. We try not to, say we need all of this. A lot of the times when we're moving from the sartorius fermenter to our large 3,000-liter tank, we will take it all because we need it. But of course, that is definitely dependent on the process. So
Joey, can I ask you a quick question?
Absolutely.
Since you're working for contract, does your customer provide all the growth conditions for the organism so that you understand exactly what you have to do? Because it sounds like you're working with so many different organisms that they would need to provide that information. I
Yeah,
can't see.
You have to
I will,
optimize them.
I will touch base on that in a little bit.
Oh, okay.
But
All right.
yeah, you're onto something there for sure. All right, so once we're inoculated, once we're in the tank, especially in the production fermenter, it is a little lax. It's not too bad. You know, usually within the first 6 hours, there's nothing to do. That's definitely strain dependent. So you know, sometimes it's a day. Sometimes if it's E. coli, it's like, okay, 3 hours, 5 grams per liter sugar's gone. Let's go. Yeah, so, and it also depends on the E. coli that we get as well. So we definitely do a lot with E. coli, but we do everything. So then once we're in there, we're watching for, depending on the fermentation, all of these variables: pH, dissolved oxygen, agitation, aeration, or feed rate, foam. Sometimes we're looking at some of the fermentation kinetics like OUR, CER, especially for high cell density aerobic fermentations, for example, E. coli, where we're growing like ODs of 350, 400, 450, which I don't even know how that's really possible, but it is. And then sometimes our automated programs, is our DO cascade working? Is DO bringing up agitation and aeration right? Is our P&IDs, the algorithms that we're using to control those working right? I have spent way too many hours overnight tuning P&IDs on the fly. I'm definitely the best at it, but that's because I've done that hours and hours and hours. And I've read about P&ID theory, and I tell you what, the books out the window, and I'm moving. I'm just changing the numbers and waiting. I've actually developed an anxiety for P&IDs going out of control. It is really weird and irrational, and I don't understand it, but it's there. But anyway, and then, you know, like we also have quality, like visual quality indicators. Like we have fermentation where like at 30 hours, if I pull it out, it needs to look milky white and have a nice sweet yeasty smell to it. If it doesn't, there's a problem. Does it smell like stinky feet? It's B sub. So, or other bacillus or whatever. So we're always monitoring it critically. We tend to have 24-hour monitoring. We try not to if we can, but we always err on the side of caution, and we do have remote monitoring and intervention if we need to. So I can get a phone call, hop on my computer, and help a more inexperienced team member who's controlling the fermentation and something's going wrong. It definitely happens a lot. So at least in the beginning.
Hey, Joey.
Right. Yeah.
Joey, this is Louise. Could you just break down those acronyms for me on the last slide? Thank you.
Sure. Yeah, absolutely. So ORP is your oxygen reduction oxygen reduction potential. OUR is your oxygen uptake rate. CER is carbon sequestration rate. Sorry, I'm not going to say that word right. It doesn't work. And then RQ is the quotient between the two. You know, DO, dissolved oxygen. Did you have any more like specific questions regarding those?
No, that's helpful. Thank you.
Okay. Yeah, no problem.
Joey, do you use computer simulation when you look at your workflow?
No, that's something we haven't really done.
There is a company called Intelligent that has a package called Schedule Pro Designer, and I use it for teaching a class. But most of the local companies that design biomanufacturing facilities in the East Coast use it to design their facilities because it lets you look at managing risk. Where is the problem going to happen? Is your CIP skid large enough for the tanks? Where should it be? What's the flow of fluids? It even lets you look at manpower and decide if you actually have enough manpower to deal with it and if you have enough utilities in many cases to do it. They have a free version that you can use to play with, and they show you a couple of different models of a biomanufacturing facility for, say, a recombinant protein. So it's a useful teaching tool. It may be worthwhile looking at it because it might eliminate some of these problems, because the FDA, when you get to that stage, is really looking now at the companies assessing risk. And that's why a lot of these firms use this package. Is it looks at the entire workflow and says, here's where we might have a problem. You know, we're transferring something from one vessel to the next. What's the problem? Are we doing it fast enough? Are we heating it fast enough? Are we cooling it down fast enough? So it's interesting to look at Intelligent, and they have a number of papers that people have written. using
Intelligent, could you write all
Intelligent.
write
It's
this in chat? Or
Intelligen. And then they have two packages. One is Intelligent Schedule, and it's sort of like Microsoft Project, and the other one is Intelligent Project Manager, or not Project Manager, but Intelligent for Design Pro. And it's a great teaching tool, because you can take a look at some of these things. Even have a factory to make beer. You know, I tell my students, you know, beer is just like what Joey's doing. You know, it's almost the same kind of. Just go to Iron Hill Brewery. It's the same kind of stuff.
Yeah.
Oh,
yeah.
thank
and
you.
maybe just as sterile. When you consider what they're doing.
Admittedly, I've brewed me many batches of beer for sure. But admittedly, this is way harder.
Oh yeah.
Way more complicated. So actually, yeah, I mean, one thing I'm going to back up just for, so I feel like this is, if you're looking at the small glass New Brunswick fermenter right next to the shake flasks in this slide, you'll see like just the spaghetti network of cables and tubing and everything. And I've been to a few fermentation facilities doing this kind of work, and I haven't seen anything neater. And it's just, but it's all there for a reason. That's, you know, the exhaust filter, the air inlet filter, everything is just, you know, on the larger tanks that's in a stainless steel housing or something, it's all there. It's just smaller, but it was fascinating to me. I mean, I remember when Mindy took me on a tour of this place, and I looked at her, I was like, you put in my application here? I'm looking at all this piping and all these tubing, and I'm like, it was very overwhelming. It's not as overwhelming now, admittedly, but there's just so much that goes on in one fermentation. I think I touched on that on this slide. So one thing that we've had to deal with a lot more recently, but we have to deal with at any given time, is contamination and failure. Sometimes we fail without contamination. We don't know why. The bugs didn't grow up. Everything was fine. It just didn't work. Yeah, admittedly, a lot of times we don't have assignable causes. Sometimes we do. You know, we had a process where we were 4 runs in. At a certain point, we had to start feed, but the bug OD wasn't there, and we're like, what's going on? What's going on? We were working closely with the client. And you know that one of their lead techs who runs this at their facility all the time, he's like, I'm telling you, it's your temperature. It's got to be your temperature. We see this with a temperature change. It's just got to be temperature. Sure enough, we look back in our data, and our temperature probe at one time point, we monitor, we log every minute on our 3,000 liter, and we miraculously caught this drastic instant temperature shift of our primary temperature probe from 30 degrees Celsius to 34 degrees Celsius within 1 minute. We almost didn't catch it, but it was right there. So our temperature probe was reading 30 degrees Celsius, and then just all of a sudden, boom, 34 degrees Celsius. Don't know why. I remember my boss and our resident electrician getting in an argument about RTDs and resistivity and how touchy they are. And he's like, yeah, it can happen. And she's like, no, there has to be a robust RTD out there that this is going to happen. It just happens. But also a lot of times we get contamination, and then, you know, when that happens, there's a lot of things that we need to coordinate with individuals who are cleaning the tank, taking things down, because at that point, you know, we're investigators. What happened? You know, we have to do a sterile hole test on our primary fermenter now, because is it in the tank? You know, and a lot of the time, I mean, I've been on every contamination mitigation since I've been in the pilot plant, and you know, a lot of times we do not find assignable causes, and we end up throwing the kitchen sink at it tapped ports and we put valves on them and steamed into them because they were borderline ASME, too big, too small, or not too small, but too large of a dead leg. Sometimes it's human error. Sometimes somebody leaves a valve open. Sometimes you go to transfer stuff out and it's gone because you left a condensate open and it dribbled down a steam trap all night. And then sometimes we get not everything we need to get from clients. Sometimes there is site-to-site discrepancies. For example, ODs. Your spec and our spec aren't the same, and miraculously they don't read ODs the same. We've run into that many times. Don't quite understand it, but it does happen. And it's not just with that. But then also of note, it's interesting, our primary fermenter is down because of this particular cause of contamination, but vessel integrity. I have a picture of one of the baffle supports on our 3,000 liter fermenter, and you can see that a long time ago, somebody had left a salty solution in the tank for like a month. And we have pitting all over. The pits are small enough that most of them are small enough that they don't cause us any problems. We do an annual sterile hold test with pretty rich media, and we pass time and time again. We also fail sometimes. In this particular case, we had failed 3 in a row, along with about $200,000 worth of runs before we failed our sterile hold tests, and we found that we had a little pinhole in one of the welds, and it was a void that was longer than a dental pick because I was able to stick a dental pick in there, and we had to get that repaired. Subsequently, after we repaired that, we found that there was a leak on the jacket. We got to get that repaired too, and it's still down. But those, failure and shutdowns can happen for all sorts of different reasons, and not necessarily the bug side of things. A bunch of stuff can happen on the mechanical side, which I will again get into, along with more specific client relations and getting all the information. But after we're done, I do want to touch base on this. Sorry for the picture, it turned out a little blurry, but those are 2 disc stack centrifuges we use sometimes to separate the broth and the bugs, concentrate them down. Sometimes we want the broth, sometimes we want the bug. It depends on if what we need is intra or extracellular. Sometimes it is the bugs. For example, sometimes it's the spores. We have a lot of biopesticide applications, and that biopesticide is a spore. So, anyway, we've done everything. We've had rotary drum skids in, we've had nanofiltration skids in, we have tangential flow skids, we've had portable freeze dryers, lyophilizers, you name it, we've done everything. Ion exchange, French press, chromatography, just everything. I haven't worked close. I've done a lot of ion exchange. I've done every ion exchange process that we've had, I've worked on. We haven't done a lot of it. But then sometimes, sometimes we're just doing it for research purposes for the client. Sometimes we're collecting it for the client. So sometimes we'll do the DSP and it gets destroyed. Sometimes we will destroy it before it gets to DSP. But there's just a lot of challenges that I unfortunately am not privy to, but they're similar challenges that we have on, for example, anaerobic. Here you go. They wanted to overlay one of our centrifuges with nitrogen to help the viability of some of these anaerobic spores we're producing. And that is not possible with our centrifuges. We've tried, but so there's all these little quirks and challenges that pop up. And then there's also packaging. Okay, we've concentrated on 3,000 liters of broth. We've got it down to 5 55-gallon drums. Now we have to pallet it right, get the bill of lading, do all of the transportation, the proper documentation to transport it. Is it hazardous? Is it not hazardous? Sometimes it is. One of our, we have butane diol on site. That is a federally regulated substance. It's one, I believe, transesterification away from being the date rape drug. It's one easy, simple chemical reaction away from being the date rape drug. Actually, in its form as is, if you consume it, it will have the same effect, which we just learned a couple years ago after having it on site for 7 years. So things like that. So one thing that is drastically different from lab scale is cleaning these things. Wow. So we, sometimes we climb in annually and disassemble our impellers, and we disassemble our impellers, clean. We don't have what you would consider sanitary design on our large scale fermenters. It is possible. I've looked into it. It's not cost effective for what we have. We would have to do a lot of engineering and fabrication. We tend to fabricate most of everything we possibly can in-house because we have the capability, and we have welders and stuff. But anyway, very complicated. This was one thing that I got early on. We had a so-so process that took like a week long to clean our fermenter, where we would fill and soak it, and we would do a quadrant. We have a spray ball, and we would do quadrants of our 3,000 liter fermenter. And by the time I got it, I knew nothing about CIP and just was learning the procedure. And I read white paper after white paper. We had a consultant come in and completely revamped our CIP. I believe it is more modern, where we have hoses like spaghetti and going into every port. And I just set it up, fill it up, run it, swap out the base for acid, rinse it. I don't have to disassemble anything, and then it's done within 1 day. So in 1 day, I can turn around our 3,000 liter fermenter, which is awesome. It's not necessarily industry standard. A lot of people like to just let the CIP cascade for hours to make sure it's clean, but I got pushed to turn this tank around as much as we possibly can. We need to run, we need to run, we need to run. So there's a lot, sometimes we are forced to do things that are outside of our comfort zone because the higher ups want us to go. And of course, cleaning a small scale fermenter is different than cleaning this one. Can't put it in the dishwasher, but you make it a dishwasher. It's awesome.
Well, Joey, at 3,000 liters, you're within the range for the single-use bioreactors and fermenters, some Sartorius or PAL or Accelerex. Is that something that the school might think of, because you might reduce some of your contamination issues, because it's, you use the bag once and you sterilize it and shred it and throw it away? We
have been told that we have about this much visibility up there in the school. So
okay.
We are, it's funny because, if you think about it, athletics, tuition, I think, we gross about $4.7 million annually. So I think we're like third for outside of federal funding for providing monies to the university. Every other department's operating in the red on grants, right? So, right. You would think they would, so when we got absorbed, they went through and they're like, yep, we have a lot of infrastructure, we have a lot of money we want to dump in infrastructure, and when we're gonna, and we're waiting. Yeah. So, we have constraints like everybody else, and a lot of those are budgetary sometimes.
Yeah, I was just thinking it might be cost effective because you wouldn't need a CIP skid, and your contamination problems might be a lot less because, you got a bag that comes in sterile and you send it out, autoclaved and shredded, and it eliminates some of the problems.
We have done. Yeah, go ahead.
So I really don't want to interrupt this conversation, but we have to move on to the next session.
Sure.
Oh, sure. Okay.
No, this is really interesting. And
yeah, unfortunately, I was just getting to the parts that are more like, this is what I didn't know coming into the industry side of things. So, but there is, I think there's, I made my slide more talking points and a lot less informative. It's not really textbook, but I think these last few slides, you can kind of get the gist of like some things that I didn't really know. Actually, I had a class at LCC that was advanced technology in the workplace, and that Mindy and this other instructor, Dr. Warden, they put together like that class translated more to what I did than any other science class I had, by far and large. Granted, you know, general chem, organic chem, biology, after 3 years of doing algebra in my head every day and doing all the other math or whatever associated with it, and like doing molarity in my head, like I get it now. I didn't get it then, and there is definitely something that can be done. I don't know what that is, but there's definitely something that can be done to make it more tangible to students. I don't know what that is, except for bringing industry to the classroom. That's what needs to happen, because it's night and day. It's not the same. You have different constraints and you're using different equipment, and you know, even if it's as mundane as a Falcon tube, you know, a 15 Falcon tube from, you know, we'll get different ones from Fisher all the time, but man, the Fisher brand Falcon tubes are better than some of the off-brand Falcon tubes we get. They are better. They're
Fisher
better
brand Falcon
constructed.
tubes are Falcon tubes. They put
I'm
their
just
label on it.
Right.
Sure. Yeah. So a 15 mil centrifuge tube,
Yep.
right? So or a 50 mil or whatever. But yeah, those kind of even those subtle differences are, you know, they affect your work and what you do on a day-to-day basis.
That's why many programs try to turn their programs into companies so they can experience that.
Yeah, I believe the University of North Carolina has a biomanufacturing, like they have like a pilot scale lab on site, and they have Sartorius fermenters, and they do like mock a big pharma work there or whatever for their students. That's definitely for industrial biotech. That is, it's essential. Like, I mean,
be careful. It's North Carolina State. That's like mixing up USC and UCLA and USC. So they'll get mad at you. Oh, that's like calling Michigan State, go blue. It's a
funny thing is I bleed blue.
Yeah. Well, you know, this is really interesting, and I don't know, do you have one more slide? Because I know that we're supposed to get going around 1:15.
I think I have just a couple, but I can sum them up.
Yeah, could you just sum them up for us? This is great.
Yeah.
Thank you.
Yeah, so you know, these 3 slides, which I haven't given to Cornelia yet, but I will, so you guys can peruse them at your leisure. But you know, fermentation is a multidisciplinary science. I mean, I have had to do, I work with DC electronics and strip wires, and I've, like, you know, that picture right there, I've done that. I do that. I do the mechanical stuff, and then I've got, you know, the Excel table. I'm making Excel documents. I've made batch records from scratch, conditional formatting. I'm writing letters to people. I'm talking to clients. I'm talking to reps. I'm using computer science, mechanics, DC electronics, AC electronics, math all day, everywhere, statistics, biology, chemistry, right? And then, but like, there's budgetary concerns, like I talked about, shipping materials, getting clients to ship materials. Are we going to buy the materials? Are you going to buy the materials? Did you give us all the information? No, that does not happen sometimes. We will be in the middle of a process where we're like, you know, they're mad at us. It's not working. It's not working. We've given you the batch record. You've reviewed the batch record. Now you're saying there's something missing from the batch record. What's missing? So, you know, it's we have to deal with that all the time. Luckily, we have a great team to vet that out on the front end. We catch 99%, but that 1% comes back to bite us every now and then. Equipment failure, you'll just be running and pneumatic hose pops off a valve and it's broken, or or you're steaming into the fermenter, and even though it's still sterile, you've added 10 more liters to the volume. It's trash. Scheduling conflicts with personnel. You know, we got to work when the bugs work, and that's probably one of the most difficult things of our job, is having the right personnel either on call or on hand at any given time. It's not easy, but Anyway,
Well, thank you so much.
appreciate it.